Okay, I think we're live. Um, okay, there was a ping, so we're definitely live. Okay. Hello world. This is day 152, I think, of studying compilers every day until I land a compiler role. Last time we finished coloring, I think. And we did a lot of cleanup work there, which was pretty great. This time, I think our plan is to just, like, get regalloc done or at least as close to done as possible. And what that involves is just like spilling now. So the idea here is there are some instances where with our current model we physically cannot fit every, I guess, live variable into a register simultaneously. So we might have to stick one into memory as a temporary. So yeah, I need to figure out how spilling works. But before that, I think I should probably figure out like spill weights. So like we want to pick the register that, I guess, gets us the most bang for our buck. So I need to figure out how to do that. I think the big book has some information on how spilling should look algorithm-wise, so I guess we will look at that. But yeah, let's, I guess, get log. Where were we? Let's go Lane, good to see you. Yeah, okay. So we need to figure out this thing here. And this also has implications for coloring, I think, because we have this like spill weight thing. So we care about that. So we will, I guess we'll have to put that on here at some point. So spill cost will also help out with this as well. Let's go, Jake Heisen. Good to see you. Okay, let's stare at the book now. We love staring at the book. It's gonna be a second to scroll here. I have a button to scroll. Nice. Okay, spill costs. So you compute costs for spilling and restoring or rematerializing registers. Yeah. Spilling has the effect of potentially splitting a web into two or more webs. I see. So the awkward thing here is we don't really use webs because we might have already done SSA destruction, so that might cause a problem or two. Yeah, not really sure where to go from here, I guess. Spilling contents memory after they're set and reloading them when yeah, okay, sure. Okay, so each element has like the spill cost thing. We probably need to like encode that somewhere. I'm not really sure how we want to do that. Estimates the cost of spilling the register in a way that resembles usage counts in 16.1. Where is this? Where is this? Okay, this... Where's this thing that they just mentioned? Yeah, we are looking at 16.1. Okay, well that's fine. Let me just figure out where I was again. Give me a second. Okay. We will just not care, I guess. Presumably it's just like, presumably it is exactly what it is described as. Okay, so So this is the cost. Uh-oh. What's good, Rami? Good to see you. How do I read this? If a website can be more efficiently recomputed than reloaded, the cost of recomputing should be used. Source of it. If the source or target of a copy instruction is spilled, the instruction is no longer. Oh, I see. That's clever. If a spilled value is used several times in the same basic block and then restored, and the restored value remains live until the last use of the spilled value, then only a single load is needed. That makes enough sense. Glup. Okay. So how do we do this? What are we doing here? Okay, so presumably these are just like user-defined weights. And by user I mean me. Compiler-defined, predefined weights. So we get all of these. So each def, use, and copy. Oh, I guess that makes sense. What is depth? That doesn't help me. Is your internship position remote, or do you need to go in an office? I think I'm fairly sure it's in person at least. Okay, what do we even do here? This is not very ideal, actually. This is a very annoying problem. Man, I wish I had SSA again. This would make this less awful. But we've already gotten rid of SSA, so oh well. Sum the cost of all. Okay, so def use. Oh lord, okay. Oh, loop nesting, that's what depth, I see. I guess that makes sense. And then real. Real is real. Okay. What the hell? Average Acrobat experience. I don't know what a better PDF reader on Windows is, so I'm stuck using Acrobat. Maybe I just use Zathura and WSL, but I don't know. It is what it is. Okay, so for each instruction, okay, so we do some like crazy pattern matching syntax. PDF and web browser? I guess that could work. I do use Firefox now, so it'd be pretty bearable. Okay, so if this is alright, so I guess we just look at all the operands. I feel like we need more info. I feel like we need more info from the middle end here. This is rough. We've already deleted a lot of info. Yeah, I guess we need to, this depth thing, we need to just like figure out where the loops exist, at least. Okay, so the spill cost we want to, I see, so we, oh, so this is the register, presumably. So it's spill cost, we add the use weight times that. Dear God, this syntax is ugly. What is happening? Why is there an up arrow? What actually are we doing here? This does not seem like very normal syntax. Okay, that seems straightforward enough. I would like to account for this, but I don't really know how to yet. Copy weight. Wait. Huh? Why is this here at least? For unary expression. And then, what is a no exp? What the hell? I'm confused. I feel like I'm just like reading into this too much. Wait, huh? Okay, let me think about this logically. So if we're copying already, so we want to prioritize spilling things that prioritize things that are getting copied, and we want to avoid spilling things that are used a lot, I guess. I guess that makes sense. Then okay. Okay, and then rematerialize this stuff we can worry about later. Dear God, this syntax is insane. And then what is real I? Or where is this used? Is it just here? Where is real I used? Am I blind? We found depth. That's one thing. Oh, okay. So surely R is used somewhere. Where is R? I feel like I'm going insane here. I actually just don't know what's happening. Is there like more code that I'm missing? What is happening? I actually feel like I'm getting like gaslit here by the book. Like, I guess I get what it's saying. This doesn't really like say much more than this stuff up here did. So I guess we'll just like try to implement this somehow. What was here? Oh, I see. Down below. Oh, I see. Oh, that's it? Wait. No way. Okay. So R is a real. So then where's the real function? The third is left as an exercise for the reader. Okay, great. So we do that. I think we do this, and then this does not do 3. Man, this stuff is hard. This spill cost stuff is hard. We might just do a simplified version here. Or we could just spill everything. That might be the easiest. But that's obviously not ideal. The third is left as an exercise for the reader. Okay. Yeah, this is what I meant last time when I was like, you kind of just have to like figure stuff out on your own a lot when you're like reading this stuff. Okay, well let's give this a try. So let's go to like, let's close out of that. Let's go to spill. Let's split this like that real quick. Let's not do spill all for now, because we can be a little bit more ambitious than that, I think. Okay, and then we have costs here. Maybe we could just do like signed here actually, unless like, we probably should do signed, because we can end up with like interestingly weighted numbers. Yeah, okay. We could just be very simple about this and just go off of like uses, but it's obviously not a perfect heuristic. Okay, so I guess stood unordered map. Alright, we could just steal that. Spill costs. Then at the end we can just return spill costs. Let's start with that, and then we can figure out what to do with that. Also with this, we should probably make like a helper, which is just like spill and then like, or like spill lowest, and it takes like the program and then like a spill cost thing. Actually, let's define a type here as well, because I don't want to pass that around a lot actually. Yeah, so we can just yoink that. Yeah, we can do that. What's good, Max? I'm doing all right. Hopefully you're doing well as well. Yeah, this code is becoming a spaghetti pile, and sometimes that's just how it is, I guess. Okay, we can do that for now. I think that's a good start. Okay. So then, we probably want a visitor for this, and we probably want like a spill code generation visitor as well. Okay, well, let's see. So let's close that out. Let's stare at this code. Yeah, so I guess we just go through all the instructions. We definitely want some sort of dynamic dispatch here. Also what we could do is we definitely want the visitor anyway, so let's define that real quick. This might be easier if we just steal code from here. Yeah, let's yoink that. And then we want to put that here, I think. Let's just do that. Yeah, let's do that. Here, we're gonna spill, costs, get result. We don't care about that. We probably want something. I don't think we need the operand manager here because we're just it's kind of just read only. So here we want spill costs. Spill costs. Sure. So let's just yoink all of that. Let's slap that in there. This visitor actually should be, or the wrapper function should not be that hard to write, so let's do that real quick. And by not that hard to write, I mean we can definitely just lift it here. And we're doing this per function as well, which means maybe I should fix this as well real quick to account for that. So function putter. Yeah, we can do that. And that might be more workable. We need to change this real quick. And then change that. Okay, let's go back to copying code from before. Yeah, I mean, I guess there's not really a lot to copy, huh? Instead of calling visitor, we want spill cost visitor. SC. Let's rename this as well. Yeah, so we can do that. We steal that. Inside of this, I don't think we need anything. We shouldn't need the constructor anymore. Presumably. We'll find out very quickly if we do need it. Yeah, so we can do that. Yippee. What a silly what a silly function. Yeah, okay. So what do we do from here? I guess we implement all this stuff, but like oh wait. Let's start with implementing this. Spill costs, there we go. Let's make a macro. Let's do that. And then, does this work? Okay, that doesn't do what I want, which is fine. We'll just 14 macro. And we'll do that again. Okay. What else? No Tokyo Night, it looks like Terrafox. Yeah, you're spot on actually. I've just been kind of messing around with the color scheme recently. Just because it's fun. There's not really much else a reason. Let's actually pick a different one while we're at it. I should probably install some more Night Fox. Ooh. I don't think I've used this one in a second. I don't know. Any color, any theme recommendations out there in the chat? Oh, Rasmus. Glove. Firefox, 1 second. Ooh. I think that seems nice. I might let's run that for a bit. Let's just yoink that. Okay. So let's not be awful with this real quick. Theme. Let's just slap that in there. I need a comma there. Let's just comment that out. Okay, we're just gonna reload new vim. Ooh, wait, I quite like this actually. Where was I again? Spill. Ooh. You know what? This is nice. This will be what we run for this stream. Okay. Maybe I should do like a theme rankings page or something just for myself. I think it'd be fun. Okay. Maybe, I don't know. I also might just get tired of like jumping around themes and just like stick with Tokyo Night for like a while again. But I don't know. It's been an interesting arc so far, so I can't really complain. It's just like Tokyo Night feels very like, it feels kind of like Vim, like New Vim Noob Trap, you know. But also like my entire laptop is Tokyo Night, so it's like I kind of have to stick with it at this point. It feels like. Okay. What do we even do here? What the hell do we even do here? Maybe we should define the spill cost as well while we're at it. Somewhere we should define spill cost. Maybe just as like constants at the top here, maybe. Uint 64 T. Or I guess these like weights for like use, copy, and def, I guess. Let's do like, I feel like I defined a constant somewhere. I do not remember where. Maybe it was in the parser? Oh god, this was awful. What was I doing? I guess the parser is going to be ugly regardless, but damn. Jesus Christ. Wow, I hate this parser. I actually hate this parser. What is the proper way to define like just a file constant? We'll just do that. We'll do use weight. We'll just do like 5 here, maybe. Static const. Oh, I forgot about const expr. Okay. Yeah. Okay. We will joink that. We'll just start with that for now. Do I just stick this outside of the namespace even? Does it matter? We'll be safe. I don't know. I do not care. Okay. So what do we even do now? So these can be no ops. Does const expr do different from const? I believe it is just like, generally speaking, const expr is like evaluated at compile time. I'm not really sure what the distinction is for like just singular constant values that don't need to be evaluated, but yeah. Does streaming help you code? I think it helps. Like the big thing is it just like gets me to actually do coding, which matters a lot. Okay, what do we even do here? uh, hmm. Hmm. Let's look up like spill cost algorithms. Compiler or regalloc spill cost algorithm. Let's see what. Okay, let's look at this maybe. Anything? Okay, let's maybe I like don't completely zoom through this. Okay, so something backend. Something. Ah, Choco Pie, my beloved. Yeah, so we're in regalloc, sure. Global allocation. This is what we care about, I guess. Okay, this is okay. So regalloc exists. Live range, sure. Oh wait, assignment. Wait, that's a word actually. It just occurred to me. We could probably rename some things actually. Instead of color registers, let's make this a sign. Do we need to change it here? No, we're good. That also means we need to change it in regalloc. And then we could also rename the visitor actually. This gets rid of this like awkward pre-color slash like color thing that we're doing. I'm not really sure what's happening there. This means we can actually we can rename things to like suck less, which is always appreciated. Wait, we literally are we stupid? Okay, I guess we could just coloring. We'll name it that. Yeah, we okay, we're doing great. Let's replace this with, I guess, reg assignment visitor? I don't know. Let's do that, let's do that. I think that's only used inside there, so that's fine. Maybe we just name it assignment visitor. Yeah, that seems less awful. Color assignment? I don't know. I don't know, tomato. I'm gonna keep this because I like how it makes thinking about it less awful. Or at least like distinguishing between the two. Let's diffs, where's backend, regalloc. Rename some assignment things for my future debugging sanity. Format, god damn it. I mean, fair enough, I guess. Ah, I see, okay. Zoop. There we go. Perfect. Okay, so then what else do we need to do? Anyway, that aside. Okay. Spilling, yeah, that's what spilling is. Dear God, this is compressed. Okay. Sure. More local, okay, global. Yippee. NP complete. Womp womp. We should probably implement coalescing, to be honest, but spilling is like 100% something we will need, so I think this is good. This is the degree. This is like the degree less than n thing. Okay, so this is the thing we've done so far. This is like, oh, this aggressively spills. Presumably we don't want to do that. We want to just do that later. We'll see if we can do things. Oh, so this doesn't include colors. Okay. Maybe we should do that, actually. That might be smart, now that I think about it. Ah, what the hell. we do not care enough. Ah, here we are. Briggs. Our boy. Yeah, so we just go for it. Wait, so we just stick a vertex on the stack. I guess this visualization makes sense. And then we just go for it. Okay. Loads and stores needed, weighted by scope. Okay. What do we do from here? Ah, yes. Okay, this is the other stuff. Okay, this is hard. TS hard. I can't lie. Coalescing we will do eventually. Okay, well, I guess this kind of helps out a little bit. Just like thinking about this at least. Infinite cost definition immediately followed by use. I see. Okay. I don't know. How do we want to do this at least? So I guess we need to think of a heuristic, but I need to use the bathroom, so I will be right back. What is this? This is like the algorithm for like spilling registers in the event we have more variables than registers live at the same time. But yeah, I'll be right back. Don't burn down the house while I'm away. You know the usual. Yeah, it'll be a second. Okay, I'm back. Alright, cool. So, I was thinking about this while I was in the bathroom. So we want to minimize loads and stores. So, I guess we could work backwards from what the spill code would look like. So, if it's a def, then I guess just like logically, if it's a def, so like if we're defining the variable, we'd want to store it somewhere. And then if it's a use, then presumably we want to, if it's a use, then presumably we want to load it from somewhere. So I think that will kind of just like make things simplify. At least we'll start with that, and then we can go from there. Yeah, but we actually, if we think about this, we actually have we've already kind of done this already. If we go back in time a little bit and we look at liveness, you will notice the genset. If we look at what all of these things are, let's just full screen this. Yeah, so the genset is all of the uses, and the kill set is all of the all of the definitions, I guess. So we can kind of reuse some of this if you think about it a little bit. This also means we should probably pass our like liveness stuff into our spill cost thing, at least. I guess this means we don't need a visitor actually, which is really nice. We can just like loop through it, and then like, yeah, we can just loop through the gen and kill sets actually, which is very convenient to be honest. So let's actually get rid of this. Let's keep it around in the event that we need it, but I don't think we need it. Yeah. What's good, Skittles? Good to see you. It's been a second. Hopefully school is going all right for you. Okay, let's ignore this boilerplate. Any tips for getting cracked with C++ and NeoVim? You just gotta use them a lot. Getting cracked with C++ requires you to just like write a lot of C++, especially writing a lot of bad C++ and then learning why it's bad. And then getting cracked at NeoVim is just like, I found taking the cold plunge and just like diving straight in and figuring out things that were slow and just like faster ways to do them helped me a lot. Like an example of this is like if I wanted to like recenter something. So if I wanted to like center the screen on like this LEA for instance, in the past I would like go down a lot and then like go back up. But then I learned like you could just like do ZZ and that centers it for instance. Just like those sorts of like micro optimizations, you'll just like eventually find pain points and you'll find ways to be faster with them. Getting settled into classes has been good though. That's good to hear. I guess that's kind of life. Okay, so we don't need this anymore. Architecture is gonna kick my ass. Yeah, that's kind of just how it is, I guess. Okay, so we definitely. Do we need the function or do we just get the? Let's look at regalloc, because this is presumably where a lot of our stuff is being called. So we definitely have liveness at this point, and we definitely have interference at this point. Yeah, so we just give it liveness, I feel like. We don't really need to do a lot more. We don't need to give it the function, we can just give it the liveness. Which is a really funny crossover here, I guess, but fair, sure enough, I guess. So let's throw this in there. Yeah, we definitely don't need this anymore, to be honest. Or we don't need this stuff up here anymore. Let's change this with const liveness. Let's see. Let's stick that in there. We're going to OOP after taking DSA. In what sense? I imagine like, I feel like DSA gives you like the language to understand OOP in some degree. Actually, no, it does not. It definitely does not. I don't know. I guess they're pretty orthogonal to each other at least. But like not in like a contradictory way, in my opinion. Okay, so we want to loop through. Oh man, okay. So tricolor we're gonna need to pass liveness in as well, actually. Which is pretty funny. Oh god, okay, this is getting a little bit insane. Maybe it's just Java though? Yeah, it definitely, I think like it's not that bad to be honest. Just Java does it in a really strict way, which feels awful. Remind me later to like talk about how Java made OOP mainstream. I want to solve this. I want to figure this stuff out first though. We'll figure out how to pass liveness in later. For now, let's just do like auto spill costs. Or maybe we just compute spill costs up here actually, because we definitely need it inside. Let's look at the pseudo code they had here. I just tried using Vim binds on Acrobat. God damn it. Okay, that's adjacency matrix. This is not what we care about. Okay. Yeah, so we want to do that here before all of this graph printing stuff. So I guess auto spill costs equals. Yeah, so we can just do this here. I guess let's do spill lowest cost register. So here we have spill costs. We want compute spill costs. Let's give it liveness. And then we can pass this into here, which I guess feels less awful. Did we forget to import this? Yeah, we did. Okay, let's stick that in there. Okay, I'm gonna... We'll worry about the rest of this later. DSA with C++. Damn, that's rough. That seems very difficult. We had this like Python-like language called like DSSL2. It's like based in Racket, but the syntax is very Pythonic. So I'm not sure how I felt about it. C++ or Java? I mean, Java is like the easy choice, but I think if you want to get good at C++, you just take the cold plunge and just do C++. Like CS GPA really doesn't matter anyway, in my opinion, unless you care a lot about like grad school. But even still, like I feel like it matters relatively less than most majors. So like, it's up to you whether you want to prioritize a number that goes on some piece of paper that will probably be looked at like twice, or if you want to prioritize your learning at least. It's up to you. I won't like make the decision for you, but you already know what I would do if I were in your position. Okay, so let's iterate through liveness. I don't know what I'm doing here, but I know I used to know what I'm doing here, so I will copy something. We iterate through liveness in interference. That's where we did it. So let's go here. It's like here, I guess. Oh yeah, okay. We can zoink that. I'm not sure why I'm passing in liveness is like mutable here. Oh wait, why am I not just... Let's make this L. Let's just make this L. Fuck it. Let's make this L. Yeah, we should... I'm definitely gonna like figure out my naming convention stuff in the future, because this is... Some of this stuff is a little bit untenable. Yeah, let's make this C. Wait, where did I change this? Assignment visitor. Let's just do that. This is stupid. Why am I fucking doing this? Let's not do that. Okay. This is all in spill and regex still, so this is fine. Some things do not need to be renamed. Let's be real. Okay, here I might want to rename it just so this all fits in one line, but it is what it is. How have your courses been? They've been alright. One of them's pretty bland. Another one is pretty bland, and another one's like actually pretty interesting. But I have to write OCaml, so make of that what you will. What is wrong with this? Oh. Whoops. There we go. So we want gen and kill instead of in and out, I guess. so we can do that. I don't think this breaks anything else yet. Yeah, let's yoink like this real quick. Do that. Kill I. What type is this? Is this a ref? We can't do that. Okay, I guess we do this. It's taking elective, trying to decide between Phil and Psych. It's up to you. I don't really know if like, I don't know. I don't really have an opinion on it. Just like whatever is cool to you, to be honest, I feel like. You coding high? I wish, man. That would be interesting. Okay. So I guess we just loop through these, and then we just modify the weights based off them. These are all registers, I believe. So, or these are all guaranteed to be registers. Actually, we don't even need to do this, because we don't need to pull it multiple times, I think. Yeah, because here we like made a mess. So we can just do like for auto reg in gen at I. We can do something. We'll worry about kill in a second. So here, spill costs at reg. What's wrong here? Oh, we need to dynamic cast it. I'm not sure why I decided to make it virtual reg. We should probably just do physical just to make things easy for myself. What are you coding? I'm making a compiler from C to x86-64. Had to take Phil's requirement for my CS3. Ah, that's interesting. I don't think I've heard of like Phil specifically being required. Let's do register. But also enforcing it by Let's just enforce virtual register. I think that's probably the safe design choice here. Every compiler error, you take a bite of an edible. that would make a funny stream actually. But perhaps it's wise for monetization for me to not promote drug use. So. Prereq for an ethics class. I see. That's fair enough then. What do we do here? I guess. So we want to get regnum if this is virtual. Actually, let's do not that. Then we can do a guard clause. Hard to code when your working memory goes out the window. True. Okay. So what do we want to do? Actually, maybe we just make a helper here and do something gross. I guess try, or I guess add, or wait. No, we need differing behavior anyway. Yeah, so we want to skip if it's virtual, or skip if it's not virtual, and then do we map these as constrained registers in liveness again? Yeah, okay. We just make the register, I guess. Get regist OM? Oh, we already, yeah, we make that. Okay. Yeah, so we have the inner reg, I guess. Okay, so we don't have to worry about constrained here, actually. So then we can do spill costs at reg, or we can static cast it. Okay, so we can do what are we doing here? Okay, so we want virtual, or we could just static cast it inside the thing. Static cast to where virtual register star. Let's give it reg. So we can do that equal and then we can plus equals, I guess, def weight. Or wait, no, this is the gen set. So gen is the uses, right? So we want use weight, I guess. I'm fairly sure I got that correct. Let's check for real. Liveness. Source. Okay, yeah. So this is the reads. Maybe we pull this out somehow. So let's do virtual reg. Let's just yoink that. Let's do that. Life is good. Okay. And then we just yoink that again. I guess we don't really need to do differing behavior that much, but we can just make this kill I. We skip if virtual, or not virtual, we do that. The nice thing is this kind of works as like a fast dynamic cast almost, which I think is kind of a neat outcome of this. In the future, once I do implement fast dynamic cast, I will try to aggressively refactor everything. Here we want def weight though. VS Code theme, Neovim, and it is this one, Rasmus. Thank you to Null Ref Pointer for the recommendation. I'm not sure if there's a VS Code equivalent. You'd have to check. Okay, so we have spill costs now, in some capacity, in a really strange capacity. How do we determine like loop depth, I guess, is the other thing. So I have loads and stores needed. It's weighted by scope. Yeah. We could start with this and then figure it out from here. I guess we could weigh this in as well. So if the okay, well, can we like not select all? Hello? Great. I should probably look at live range splitting at some point. I don't really know what to do with it though. Or what a good heuristic for this is, at least. Yeah, this is hard though. Okay. Yeah. So we can look at the gen and kill sets, I guess. I don't know. We'll give this a shot, I think. I think this is probably a good start. What do we do? So we have spill costs now. And we don't need this giant slush pile, thank goodness. Yeah, let's start with that at least. And then we can get rid of this in here. That helps clean things up a little. Yeah, so we have that now. Let's go to Regilock again just to figure out where we are. First, we definitely need to pass this into color here. So spill costs, and then we'll update everything to use it at least. Maybe we just like shorten these names as well. Yeah, maybe we shorten some of these names. Or at least we just shorten liveness and interference, maybe? I don't know. Let's do L. Because we pass these around a lot, so. Well, okay, I guess that doesn't fix anything here, so we may as well just leave it in. Okay. So let's go to, what are we adding? Coloring. So for that, we want to add in, we don't care about it in assign registers, we care about it in tricolor. Let's start with this. Let's commit some stuff real quick. We compute spill costs. Yippee. Okay, let's add that back. What else do we want to do here? So we want tricolor. We want to add this here. So we want spill costs. Let's give it SC, I guess. Let's make this. We could keep this as interference, I think. Or we can make this like IG, like interference graph. I don't know. We'll figure that out later. That might actually be smart. Just to condense things. I don't know. Naming is hard. Naming is really hard always. What do we need to update? Tricolor. There we go. And then we want spill costs. We can do that. We could probably const this as well. Yeah, we can do that. Life is good. So now we want to do it here, at least. What do we do here? I guess spill costs. What did we name this again? SC. Yeah, we have SC. So if it contains reg, or actually we could just do this. Actually, we could keep that as is. We just replace something here. So if it's a virtual register, then we do sc at reg, or static cast. This is unfortunate. We want static cast to virtual register star. Oh god. Maybe I should just make this a register just to make this less awful to use. I might just do that real quick. I do not care about enforcing correctness here, I think. Like, I care, but not enough to handicap the rest of my code, at least. Where does this live again? Spill. Or here, I guess. Register star. Yippee. We can just get rid of that even. What's good, Ranch? Good to see you. How's it going? That skips that static cast there. We also can skip that one there. Okay, we don't have more static cast there. We should fix this up. There we go. Much better. What is register splitting? Is it splitting big values between two registers? Okay, wait. Where's splitting coming from here? At least. But that register splitting, I don't really. That's not really a thing, I guess. The way you're describing it. Okay, this looks good, this looks good. Anything else I need here? Yeah, okay, we could do this. What is register spilling? If we don't have enough physical registers for all of the, I guess, virtual registers at the same time, we will need to put one in memory. We need to put one in memory somewhere, so, yeah. Lane is spot on. Yeah, so if we have like 16 registers and 17 variables, we need to put one of them in memory somewhere. And the idea is we just pick the one that is cheapest to move to and from memory. But we don't really have a great heuristic for this yet. What is min-val? I guess min-weight, I guess? Yeah, let's do that. I guess cheapest weight, I guess, and then we can do like I hate renaming things. Let's just do weight. No, let's do that. Okay. So let's make this might hopefully this still works. This will still break with a lot of tests, but as long as this like does something here. I think it did something here. This at least works still, which is good. I don't think this changed anything that's visible, but at least it still works, which is good. Using built-in AI plugins on Nevim sounds so wrong, but I don't know why. I don't know. I think it's fine. I just don't think it fits my workflow personally. I don't know. Someday I will probably try out Cloud Code just for fun, but we'll see. We'll see what happens there at least. What else do we do here? I think this is good for that at least. I don't think we need to do a lot more explanation here. So let's... What did we change here? We literally just changed that. Okay. Let's add that real quick instead of diff. So here we use register instead of virtual register because I'm lazy. Set that. Unless we're gonna stick to the old way. I mean, I guess like I kind of get where that comes from. Like, generally when you think of like a Vim user, you think of someone that has like been in the industry for a long time, and like you know how people that are very comfortable with their tooling are do not particularly enjoy workflows that completely upend their current workflow. So I think it makes sense. But I don't know. Like, I guess I see where you're coming from. I just don't really think you're correct in that aspect, at least. Okay, so then here we use spill costs in degree less than R. Okay, cool. Cool. That all fails, which is fine. We'll worry about that later. O0 still fails because we haven't spilled yet. We need to figure out how the hell we're gonna spill though. That scares me a lot. What's good, Swasibaka? What's the philosophy behind your compiler and why you're not using something like LVMIR? I mostly just want to like learn the motivation behind the existing infrastructure. So part of this just comes from like rebuilding a lot of stuff from scratch, both the middle end and the back end. And yeah, I guess it's also just kind of fun to like do this because then I can also benchmark against it and then see how I'm doing at least. Okay. So now we need to spill. How do we spill? Spill lowest cost. And let's give it the function. And then let's give it, or we don't need this. We want spill costs. We'll just do that. I don't know. Let's just yoink that. Let's stick this here. We'll do that. Let's throw that down there. Okay. How do we get the min value? Or get min value, or from unordered map C++. Is there like a std min element? Yuck. Okay, we could do that. Yeah, oh then, okay, sure. That's fair enough. Yeah, I think the more you try to use AI for something, I think the more of a mess it makes in general. But also, like, it's very case by case. It's kind of interesting to think about. Like, I think of it sort of like cheating in video games, or like using a chess engine, right? Like, if you're using it to do everything, like, you will not have a great time. But, like, if you're using it and like critical, if you're using it in like critical moments, I think it would, I think that might like make the usage a little bit more powerful, at least. You might want to try std map. I thought about it. I like, if I'm just like iterating across this once, or at least like if the only time where I can save time with like lookup is specifically just like in this function, I don't really think it's worth the insert cost, at least. Like, unordered map will do, I think. Yeah, we might just have to like iterate across this, but if there's like a nice like C++ std ranges min value from unordered map. If there's like a nice way to do this, I guess we could just, Okay, you know what? This is just gonna be ugly regardless. I think we just do a for loop. Yeah, let's just get the min cost. Or I guess min reg, min cost, or let's just be gross with this. Min cost equals -1. Or I guess let's just do the thing above. Range is min element, yeah. But then I saw lambda and I was like, this is gonna be ugly anyway, so it's just kind of doomed, I guess. It is what it is. Yeah, there's just not really a clean way to do this. I don't, like, if it's gonna iterate through it in its entirety anyway, I don't really think I don't really care enough, I think, to, I guess, increase the maintenance cost in that regard. Let's do that. What did I paste over? Oh, I see. Whoops. Sort of remaining, we want, I guess, SC. Yeah, we can do that, I guess. Let's do cost here instead. Unless 4K, true. Yeah, it's crazy to think about, actually. 4K is a lot of people. It's definitely a lot of people. Let's count lines of code. Yeah, 4K is double the amount of blank lines I have here, which is incredible. Yeah, I don't know. I feel like AI getting 90% of the way there is like, it feels like we're solving the wrong problem, right? Because like writing code, I don't think has ever been the hard part, at least. The hard part has always been like designing things. And like AI is quite bad at that because, well, it copies the most popular wrong answer sometimes. But it looks correct, so that would not go very well, I think, in the average case. Let's do ref here. So if cost. What am I doing here? Oh, I need to add braces. Let's do that, and then min cost is cost. And then I'm too lazy to type, so I'm actually just gonna yoink this here. Very inspiring. Do you have any formal education before this, or is it mainly self-taught? I have taken a compilers class before, and I've done a little bit of like academic research, but beyond that, not really too much. Do you use Clang Tidy? No. I probably should, huh? That'd be an interesting pal to look at. Do I have Clang Tidy? How do I use this? I should definitely use Clang Tidy. Let's see how long this output is if I use this. Oh, let's see. Fine. Okay, let's do source. Find all file cpp files. Clang tidy on directory. Bear. Okay, what are we doing? Okay, we do that. Oh, wait, this is a thing? Oh. Neat. Wait. Uh-oh. Null pointer? Okay. This, sure, fair enough. Okay, well, this actually turned out a lot less bad than I thought it would be. Yeah. Okay. Is there like Clang tidy pedantic or something? Clang tidy all checks. Ah, here we go. Yeah, I should make a Clang tidy config. What is like a sane pile of Clang tidy? Annoying and opinionated, fair. What checks? Let's see what Reddit says here. Embedded. As many as you can stand. That seems fair enough. Core guidelines, okay. I guess that makes sense. So how do I run this again? Dash dash checks equals. Oh yeah. CPP core guidelines. Clang tidy CPU core guidelines. Ah, dash star? I see. Eh? Oh, wait. Am I... So dash checks. Just this, I guess? Or maybe... There we go. Oh, dear God. Okay. Glup. Okay. That's scary. That's a lot of warnings. Huh. Magic number. Okay, like, fuck off. Okay. Okay, that's fun. Well, this is fun. Do you not use static cast to downcast from base to derived? We've checked already. We don't care. Yeah, okay. So let's... Maybe I'll just do like the default. I'll just do the default and call it a day. But let me just add a note for myself to do cling tidy setup proper. Yeah, I mean, core guidelines star. I imagine like that made sense. Okay. Let me catch up on chat proper for a second. Yeah, this is definitely where someone that enjoys Rust would enjoy it a lot, or would have a fun time dogging on C++. Let's do something with this for now. Yeah, so we spill F and then min reg. Hey, gonna take your job, little bro? I'd like to see it try. Actually, I'd be very happy if it took my job, because I'm currently unemployed, so... if AI takes the unemployment, I would not complain whatsoever. Like, that's the whole point of the stream, as a matter of fact. Are you still in school? Yes, I'm finishing my undergrad degree, and starting up my master's at least. Okay, so here we spill. We actually do the spill. What are we doing here? Glup. How do we generate spill code? It's actually very annoying. I guess we could just like... Gen and kill would be helpful here, I think, but... Sort of, but like not really. I don't know. This is kind of awkward. Does this have any like spill code generation examples, maybe? I'm fairly sure this does, actually. But I don't think it's gonna be particularly meaningful. Unless there's like a special way they like store information that might be easier to work with. Actually, yeah, this might be easier if I just pass liveness to it, but I don't know. I guess it probably will be. Okay, we're in spill cost again. Pruning, register assignment, spill code, okay. How is use weight and copy weight calculated? I made it up. There's no calculation. Okay, so we check each definition and use to determine whether it's marked to be spilled. Compute displacement and insert. Oh, I see. That's quite annoying, actually. Hmm. Hmm. Maybe I save this for next time, actually. I don't particularly want to do this tonight. Let's just print something. Yeah, let's do this. We'll just be stupid with this for now. What's good on Finscove? I don't think I've seen you around, so welcome to the streams. Seems like a very fun series. I hope it is. I imagine there's some streams are boring, but that's kind of life at least. Okay, let's see what this vomits out. Yeah, we'll just leave that as this for now. Works only when the devs use and only for portfolio sites? I think yeah. I think the other big thing is just like readability as well. Yeah, cause you try to read the code and it is literally just a slot pile. Okay, that's fine. Oh, I'm not calling spill. I see. Let's go back to regalloc. Yeah. So we want spill lowest cost. Let's give it F or F putter. Actually, we can rename this actually. Unique F. And let's make this F. Yippee. Everyone is happy now. Even crappy preference for Vanilla.js? Honestly, I think so, yeah. I don't know. It goes, again, most popular wrong answer very frequently, I think. Okay, so we have F and then we have spill costs. So let's give it spill costs. Let's make. Let's shorten this. And let's do make build so we don't run all the failing tests again. Zoop. Okay. Reg 91. Okay. Okay, cool. Okay, I think this is like a pretty reasonable place to be. Scaffold, spill, lowest cost, I think. What got you interested in compilers? The compilers class I took. I initially took it on Adair because it was notorious for being 20 hours of work a week. And one of my friends was like, I'll take it if you take it. And I was like, okay. And then 2 weeks in, I was struggling because it turns out writing C++ code specifically for regalloc, which funnily enough is where I am now. Writing C++ code for regalloc when I've not written C++ code for a year is a pretty miserable experience. And then after I relearned how to write C++ code even remotely, it turns out the content is kind of interesting because it combines kind of all of the programming or all the computer science fields that subfields that I enjoyed. So there's obviously the PL aspect and the architecture aspect, which have a lot of depth, but then there's also a lot of software engineering that goes into it because, well, maintaining compilers is rough because they are an engineering nightmare. And there's also the theory side, just with all the algorithms. And I thought it was really cool that you kind of just have the intersection of all of those. So after the class, I reached out to the professor and I did research. So it's been 2 years of that, and here I am, I guess. I'm still doing research for the same lab for my master's, so maybe I'll have like a presentation on that at some point. Maybe I won't. We'll see when the time comes, at least. Oh, I need to format. Zoop. Okay. Let's commit. Actually, we can just steal that. Okay. I think we just tackle this next time, because I think I'm out of brain cells for this stream, unfortunately. I also have some homework I probably want to get done before tomorrow. How does research work for a master's? I mean, like, thesis-wise, it's kind of just like any other, like, thesis. Like, you kind of just do what interests you, I guess. It's a lot of just, like, data analysis, to be honest. Not a lot of, like, engineering, which I guess I get my fill of through streaming proper. Yeah. So, like, right now I'm just, like, running a lot of benchmarks, which really sucks, because I need to, like, I would like to have, like, some sort of, like, a pipeline set up, but it turns out every benchmark just, like, has its own runner. And then I also have to worry about, like, running C versus, like, Rust benchmarks. So, like, so much mess. It's freaking awful. It's definitely turned me away from, like, long-term doing, like, more analysis-y research, but, yeah, it's like, meaningful in some way, I guess. But yeah, I'm gonna have to call the stream here. I also want to eat more dinner, so yeah. Yeah, thank you all so much for showing up today. If you haven't already, make sure you like the stream, sub to the channel. It helps out a lot with the algorithm. While you're down there, I guess check out the description. My Discord is there. Best place to get pinged when I go live. How do I start with programming? Learn some C++ and HTML. Just make some projects. Think of something you want to do, and I guess just build it. Also in the description, just finishing this up, is my LinkedIn, my GitHub. Add me on those if you wish. And yeah, I guess. Also my GitHub sponsors is down there if you want to give me money, I guess. No obligation. Yeah, that's about it. Take care, y'all. Take it easy. And have a wonderful rest of your day wherever you are.